Space mission. Space missions are the missions which are undertaken for observing various objects in our solar system. Types of artificial satellite. Artificial satellites are the man-made objects which revolve around the Earth or any other planet in a fixed orbit. The different types of artificial satellites are the weather satellites, communication satellite, broadcast satellite, navigational satellite, military satellite, and Earth observation satellite. There are three types of orbits in which these artificial satellites revolve, namely, the high Earth orbits, which has a height more than 35,780 kilometers from the Earth's surface. The medium Earth orbits having height of about 2,000 km to 35,780 km from the Earth's surface. The low Earth orbits having height of about 180 km to 2,000 km above the Earth's surface. There are various space missions which are carried from various countries around the world, such as the Moon mission and Mars mission. Space mission. Substantial developments in technology, especially space technology, in the latter half of 20th century resulted in the development of spacecrafts, making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We will learn about all this in this chapter. We can classify the space missions into two categories. In one type of missions, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of second type of missions is to send the spacecrafts to outer space for close observations and understanding of the objects in solar system or even outside the solar system. Need and importance of space missions. The world has become a global village due to space missions. Today we can contact a person in any part of the world within a second. We can gather information about worldwide events sitting at home. You all know the importance of Internet. Due to Internet, every information is available at our fingertips. It has become possible to get advance alert about natural calamities and take proper precautions. During war, it is possible to get information about the actions of the enemy through aerial surveillance using satellites. It is also possible to explore the fossil reserves and minerals in the Earth. Thus, there are unlimited applications of space missions. Today, space technology is an inevitable part for development of a nation. A natural satellite is an astronomical object orbiting the Earth or any other planet. The Moon is the only natural satellite of the Earth. Some other planets in the solar system have more than one natural satellites. Similarly, if a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. The first artificial satellite, Sputnik, was sent to space by Soviet Union in 1957. Today, more than 1,000 satellites are orbiting the Earth. The satellites work on solar energy. So solar photovoltaic panels are attached on both sides of these satellites like wings. Instruments are installed in the satellites to receive the transmit signals from and to the Earth. All artificial satellites do not revolve in similar orbits around the Earth. The functions of the satellite decide the height of the satellite's orbit from the Earth's surface. The nature of the orbit and whether the orbit shall be parallel to equator or making some angle with it. To put the satellite in its proper orbit at specific height above the Earth's surface, the satellite is taken to that height using a satellite launcher. Then the satellite is given a specific velocity known as the critical velocity (vc) in tangential direction to the orbit. The satellite then starts revolving around the Earth. The formula for the velocity vc can be derived as below. If a satellite of mass m is revolving around the Earth in an orbit of height h with speed vc, a centripetal force mvc square upon 2 will act upon it. This centripetal force is provided by the gravity of the Earth. Therefore, centripetal force is equal to gravitational force between the Earth and the satellite. It can be seen that the critical velocity does not depend on the mass of the satellite. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. Depending on the height of the satellite's orbit above the Earth's surface, the satellite orbits are classified as below. High Earth orbits. These orbits have a height greater than or equal to 35,780 km above the Earth's surface. A satellite revolving in a high Earth orbit will take around 24 hours to complete one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of revolution for the Earth around itself and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to the Earth. For a passenger in one vehicle, another vehicle moving parallel to him with equal velocity appears to be stationary. This is what happens here also. These satellites are, therefore, called geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. Medium Earth orbit. If the height of the satellite orbit above the Earth's surface is in between 2,000 km and 35,780 km, the orbits are called medium Earth orbits. The geostationary satellites orbit above the equator. These are therefore not useful in the study of polar regions. For this purpose, elliptical medium Earth orbits passing over the polar region are used. These orbits are called polar orbits. In these orbits, the satellites complete one revolution in 2 to 24 hours. Some of these satellites revolve in circular orbits at a height of around 20,200 km above the Earth's surface. Global positioning satellites revolve in such orbits. Low Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 180 km and 2000 km, the orbits are called low Earth orbits. The satellites used for scientific experiments and atmospheric studies revolve in low Earth orbits. Depending on the height of their orbits, they complete one revolution in around 90 minutes. International Space Station and Hubble telescope also revolve in low Earth orbits. Satellite launch vehicles. Satellite launch vehicles are used to place the satellites in their specific orbits. The functioning of the satellite launch vehicle is based on the Newton's third law of motion. The launch vehicle uses specific type of fuel. The gas produced due to combustion of the fuel expands due to its high temperature and is expelled forcefully through the nozzles of rear side of the launch vehicle. As a reaction of this, a thrust acts on the vehicle, which drives the vehicle high into the space. The structure of the launch vehicle is decided by the weight of the satellite and the type of satellite orbit. The fuel of the vehicle also depends on these factors. The fuel forms a major portion of the total weight of the launch vehicle. Thus, the vehicle has to carry a large weight of the fuel with it. To overcome this problem, launch vehicles with more than one stage are used. Due to this, the weight of the vehicle can be reduced step by step after its launching. For example, consider a launch vehicle having 2 stages. For launching the vehicle, the fuel and space shuttle separation of booster rockets, separation of fuel tank satellite is launched in its orbit, and space shuttle returns to Earth engine in the first stage are used. This imparts a specific velocity to the vehicle and takes it to a certain height. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached and the main body of the vehicle and fall either into a sea or on an unpopulated land. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. However, the vehicle now contains only one, that is the second stage. The weight now being reduced, the vehicle can move with higher speed. Almost all vehicles are made of either 2 or more stages. As an example, the structure of a Polar Satellite Launch Vehicle PSLV developed by ISRO of India. The launch vehicles are costly because they can be used only once. USA has therefore developed Space Shuttle, which returns to the Earth except for the fuel tank and can be reused in multiple launches. Space missions away from Earth. As we have seen above, artificial satellites are being used for making our life more and more enriched. However, in the previous standard, we have learned about how the telescopes aboard artificial satellites are used to gather information about various objects in the universe. Similarly, some space missions are used to gain further knowledge about the universe. In these missions, spacecrafts are sent to the nearby objects in the solar system to observe them more closely. New information has been obtained from such missions, and it is helping us to understand the creation and evolution of our solar system. For such missions, the spacecrafts must escape the Earth's gravitational force to travel into the outer space. To achieve this, the initial velocity of the moving object must be greater than the escape velocity of the Earth, as we have learnt in the chapter on gravity. Escape velocity on a planet can be obtained using following formula. Escape velocity is equal to root of 2 into the gravitational constant into the mass of the planet upon the radius of the planet. Moon missions. Since the moon is the closest astronomical object to us, the first space missions to objects in the solar system were the missions to the moon. Such missions have so far been executed by USA, Soviet Union and European countries, China, Japan and India. The spacecrafts in the Luna series sent by Soviet Union reached near the moon. Luna 2, launched in 1959, was first such craft. After that, till 1975, 15 spacecrafts made chemical analysis of the moon and also measured its gravity, density and radiations. Last 4 crafts even landed on the moon and brought the samples of stones on the moon for analysis in the laboratories. America also executed moon missions from 1962 to 1972. The speciality of these missions was that some of these were manned missions. In July 1969, Neil Armstrong became the first human to step on the moon. In 2008, Indian Space Research Organisation ISRO successfully launched Chandrayaan-1 and placed it into an orbit around the moon. It sent useful information to Earth for about a year. The most important discovery made during the mission was the presence of water on the moon's surface. India was the first country to discover this. Mars mission. Next to the moon, the astronomical object nearest to the Earth is the Mars. Many nations send spacecrafts to the Mars. Mars mission is difficult and almost half the missions were unsuccessful. However, ISRO's performance in these missions is remarkable and we all must be proud of it. The spacecraft Mangalyaan, made by ISRO using the minimum expenses, was launched in November 2013 and was placed into orbit around the Mars in September 2014. It obtained very useful information about the surface of the Mars and the atmosphere around it. Indians who have traveled to space. 1. Rakesh Sharma. Rakesh Sharma was the first Indian to travel to space. He went into space along with 2 Russian astronauts under the joint Indo-USSR space program. He stayed in space for 8 days. 2. Kalpana Chawla obtained her engineering in aeronautics degree from Punjab and in 1988 obtained her doctorate from University of Colorado. She was in space for 336 hours during research mission. While returning to Earth from space on 1st February 2003, the Columbia spacecraft exploded and Kalpana perished. 3. Sunita Williams traveled to the International Space Station in Space Shuttle Discovery in 2006. She worked for 29 hours outside the space station. She created a record by staying for 192 days in space. India and space technology. India has made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed by India to put satellites having weight up to 2,500 kg into all types of orbits. PSLV and GSLV are 2 important launchers. The scientific and technological feats achieved by India in this field have a significant contribution to the national and social development. INSAT and GSAT satellite series is actively working in the field of telecommunication, television broadcasting, and meteorological services. Availability of television, telephone, and internet services all over the nation has been possible due to these satellites only. EduSat satellite in this series is used specially in the field of education. IRS satellite series is working for monitoring and management of natural resources and disaster management. To exactly locate position of any place on the Earth's surface in terms of its precise latitude and longitude, the IRNSS satellite series have been established. Vikram Sarabhai is considered as the father of Indian space program. His efforts led to foundation of Physical Research Laboratory PRL at Ahmedabad. In 1962, Indian government constituted Indian National Committee for Space Research under his chairmanship and first satellite launch center was established at Thumba in 1963. The launching of India's first satellite Aryabhatta into the space was the result of his efforts. He played an important role in the establishment of Indian Space Research Organization ISRO. Space debris and its management. In addition to the artificial satellite, some other debris is also revolving around the Earth. It includes non-functional satellites, parts of the launcher detached during launching, and debris generated due to collision of satellite with other satellite or any other objects in the space. This debris is increasing day by day. It is therefore very essential to manage the debris.